Welcome, everyone. Get ready because today we are going to completely master lines and angles together in this revision explainer. Let's do this.
Well, it turns out they're all packed with hidden lines and angles that follow some very special rules. And today, we're going to uncover every single one of them.
So here's our game plan for today's training session. We're going to build our skills right from the ground up until we are totally ready for that final challenge.
Okay, let's dive right in with a quick warm-up on the absolute fundamentals. You gotta know the tools before you can win the game, right?
First up, let's get our toolkits sorted. You've got your line segments, which are locked in with 2 endpoints. Then you have rays, which have 1 starting point and just shoot off forever in one direction. And of course, lines, they just go on and on forever in both directions. Now, the magic happens when any of these meet. They form an angle at a point we call the vertex.
All right, time for our first round of training. We're gonna look at angle pairs that have a really special relationship based on, well, what they add up to. First on the list, complementary angles. Now here's an easy way to remember this. Think corner. You know, like the corner of a square or a book? That's a perfect 90-degree angle. So if 2 angles fit together to make that 90-degree corner, they complement each other.
So let's do a quick check. You have a 70-degree angle and a 20-degree angle. Do they add up to 90? Yep, 70 plus 20 is 90, so they're complementary. What about 63 and 27? Add them up, and yes, 90 degrees on the dot. You've totally got this.
Next up, we have supplementary angles. For this one, I want you to think straight. A perfectly straight line is always 180 degrees. So if you have 2 angles that can sit together on a straight line, they add up to 180, and we call them supplementary.
Now this is where seeing them side by side is super helpful. Complementary, think C for corner, 90 degrees. Supplementary, think S for straight, 180 degrees. And here's a cool little detail. 2 right angles, that's 90 plus 90, add up to 180. So they can be supplementary, but they can't be complementary. It's these little rules that make all the difference.
Okay, let's move on to our next set of skills. Time to learn some combo moves and see what happens when angles are right next to each other.
Adjacent angles are pretty much just neighbors. Think about it. They share a corner point, the vertex, and they share a wall, or an arm in geometry terms. But the key thing is they don't overlap inside. They are simply side by side.
Now, a linear pair is a very special kind of neighbor. These adjacent angles sit together so perfectly that their outside arms form a single straight line. And what do we know about a straight line? It's always 180 degrees. So a linear pair will always be supplementary.
Okay, get ready for a power move, vertically opposite angles. This one's easy to spot. Anytime you see 2 straight lines crossing each other, they make a perfect X shape. The angles that are directly across from each other in that X, those are your vertically opposite angles.
And here is the crucial point, the golden rule you have to remember. This isn't a sometimes thing, it's an always thing. Those angles directly opposite each other in the X are always, 100% of the time, equal. Lock that one away. It's super important.
All right, it is time. Let's enter the main arena and face the transversal. This is where all those skills we've just been practicing finally come together.
So what is this big, scary transversal? Honestly, it's just a line that cuts across 2 or more other lines. That's it. Think about a city map. If you have 2 parallel avenues, that street that cuts across both of them, that's your transversal.
Now, here is where the real magic happens. When that transversal cuts across 2 parallel lines, it creates a whole system of angles that follow predictable rules. Certain pairs of angles are guaranteed to be equal, while other pairs are guaranteed to add up to 180 degrees.
And I'm going to let you in on a secret for spotting these relationships. Secret trick number 1, look for the F shape. Now this F can be forwards, backwards, even upside down. But if you see it, the 2 angles that are tucked into the corners of the F, they're called corresponding angles, and they are always equal.
And the other secret weapon? It's the Z shape. Just like the F, it can be forwards or backwards. The angles that get tucked into the inner corners of that Z are called alternate interior angles. And guess what? They are also always equal. Remember F and Z, and you'll be unstoppable.
You have trained hard. You have learned the moves. And now, it's time for the final challenge. Let's put all this new knowledge to the test.
Okay, check out these intersecting lines. See that X shape?
We know the angle at the top is 55 degrees. So what are the values of x, y, and z? Go ahead and pause here for a moment and work it out.
Okay, you ready? Let's break it down. Angle x is directly opposite that 55-degree angle, so it has to be 55 degrees too. They're vertically opposite. Now, angle y sits on a straight line with the 55-degree angle, making them a linear pair. So we do 180 minus 55, which gives us 125 degrees for y. And finally, z is vertically opposite y, so z is also 125. How'd you do?
All right, here we go. The final question. We are told the lines L and M are parallel, and they're being cut by a transversal. If that top angle is 110 degrees, what is the value of x? Go on, pause and use your F-shape and Z-shape knowledge. Ready? The answer is 110 degrees. Why? Because angle x and the 110-degree angle are in the exact same position on each parallel line. They make a perfect F shape, which means they're corresponding angles, so they have to be equal.
And just like that, you have officially completed the geometry gauntlet. You've learned the moves, you've aced the challenges, you're an angle expert. So here's your final mission. As you go about your day, keep your eyes open. Where are you going to spot these hidden F and Z shapes out in the real world? You'll be surprised how often you see them now.